1024 on 768. Because this is the native resolution of the projectors.
Right, let's see where we can change that. Display. What is that?
1024.
This one or this one?
Oh, yeah.
Okay.
I will turn the other projector after the.
Sure.
Okay.
Sure, no problem.
Co je to?
Jo, dobrý. Přesně, koukám tady. Já jsem samotný těch marketů. Jsme to říkali, první... Víš, jak to říkejte? Jakoby jednou za čas, jo. A že okay.
Let's set up your mic.
Mm-hmm.
I touch it to the side.
Mm-hmm.
You saw something?
Something.
Okay.
Cool.
Can you do it?
Turn it on. Make it set. We have 40 minutes, right?
Yeah, 3 minutes.
2 o'clock we start.
Totally okay. I'm sorry, but how do you spell your name?
Maciej?
Maciej? Okay.
Problem, everyone has problems with that.
Sorry. Where from?
Poland.
Poland. Okay. I think that kind of. So okay, I want to tell you one quick note. You can still present some subjects for lighting talks, which will be held in 17:30 in D105. It's still voting for some topics. Okay, we can start. Let me introduce you, Maciej Swiderski. Is right? He will tell you something about jBPM, BPM Smith knife. It's yours.
All right. Let's put that here. All right. Can you hear me? Here. All right. So let's start with quick introduction to what we have here. So jBPM as a BPM Swiss knife, as we used to call it, it's a very short presentation as we have 40 minutes, but I would like to go over both BPM as a discipline and principles of BPM, and then going through jBPM as one of the implementations that can actually be used for automation of our business knowledge. So starting with what the BPM actually is. So BPM as a term stands for Business Process Management, and by that it mainly focuses at capturing the business knowledge that we have in our domains and to be able to capture it in a structured way. At the same time, as we can see here, we have a different life cycle phases of BPM, and that allows us to go over the projects in BPM or the work we do with BPM in an iterative way. So we follow the different phases, like discovering the business knowledge that we have in our domain, formalizing that by building different models, different sets of artifacts or assets that we can actually later on consume in BPM itself as the solution. Implement, run, and monitor. This is like three phases that are very close to each other, and based on that we can actually assess how we can improve our environment and our business knowledge within the BPM ecosystem. Based on that, we can once again iterate over all the phases or some phases that we believe are required for a given scenario. So again, the most important is that it's an iterative process. We don't consider it at any time to be actually final or complete version, because we would like to encourage and promote the change, because this is what actually brings benefits and profit to our businesses. By doing that, we actually sort of by default increasing visibility of what is actually running in the systems and what is consuming our processes. Based on that, we can actually see how things are running and how they can be improved. But yeah, talking about the business process management, but what actually the business process is, and I'm quite sure that you can find a number of definitions out there, and one of the most important, the simplest one, and I'd like to always refer to that, is the business process actually a set of steps that executed in given order will achieve a certain business goal. And again, this is all the most important part in this definition is that it's actually business goal. There is nothing else in like technical stuff or IT related things. All that we wanted to achieve is a business goal. And once we have that, we can actually define a set of steps that goes into that or help us to achieve that goal. And we can then define different successful or happy paths, so-called, or we can have exceptional flows and so on. But then one would ask why we actually need or why we would use BPM. Because we can actually implement the same stuff with every single coding or language, whatever we choose. But the best, I think, the aspect of using BPM is actually the business and IT alignment. Even though this is not easily achievable, because those people that work on the business side, people that are working on IT side usually speak different languages. But with BPM, when focus is actually on the business aspects of it, I think it's way easier to understand each other and always work on the artifacts that are actually executable. So when we have the process definitions, you can actually discuss that with the business and make sure that this will be well understood by both parties and executed in the same way. With that, we can actually use the layered or hierarchical approach. Try to avoid, whenever you define business processes, try to avoid too much details in them. You have the options to go down and drill down from one level to the other. So going through at different levels of the hierarchy in your processes, you can achieve more visibility and clarity in actually the business assets you are working with. Again, with different phases, and they are iterative, we can actually achieve very easy continuous improvement. Whenever we run something, we grab information of how it was executed, how much time it took, how many people were involved, where we see bottlenecks, and so on and so on. Based on monitoring data, we can instantly take from the runtime environment. We can actually improve the running environment. And by that, I mean both processes and the actual infrastructure behind them. And this comes down with increased agility and monitoring that is covering the life cycle phases as well. And then last but not least, the speed of development. And this is kind of a tricky argument to give, that, how we can measure speed of development. Of course, introducing any new technology, regardless if it's only IT technology or it's a business-related stuff as well, because BPM is all about the business. So it's not only IT technicians that needs to understand that the same thing must be rolled out on the business side. So these people must work together and make sure that they understand each other, first of all, and the same produce a really efficient results out of their work. So development will increase in terms of speed whenever people are already up to speed with actually understanding the principles. The underlying technology, is it jBPM, is it other vendors or BPM projects, doesn't really matter, because this is just implementation details. Of course, they will enforce different ways of interacting with the BPM principles, but the most important are actually to follow them. Once you follow them, you understand how the business can be captured and how they can be actually documented and executed later on, then you're already on a very good spot. So business processes focuses mainly on actually the business aspects of it. The technical side is just put aside. It's just, this is something that needs to realize what we actually developed here. And by develop, I mean the business, capturing business knowledge and documenting that. A quick run through BPM in general. So now let's look at BPM from jBPM point of view. And jBPM is part of the umbrella project called Knowledge is Everything, and that means actually what it stands for. So knowledge is everything. Whatever jBPM operates on is actually considered a knowledge. So processes is a knowledge. Business rules is a knowledge. Data model that rules and processes operate on is a knowledge again. So once captured that, you can actually benefit on the different layers whenever executing those. They can again be improved, they can be changed, and they should be actually. That's why we have a notion of versioning. Those assets can be versioned. Processes, rules, data model can be all versioned. So they can independently run even on the same execution environment without interfering with each other. So that's why they are all considered as a knowledge. Quick overview of the landscape of what jBPM as a project delivers. So in the middle we have the core engines and human task service. This is actually the runtime component that can execute the business assets. So this is consuming the business process definitions and user task lifecycle. Optionally, but in usual cases, persistence is included as well, because for long-running processes, including user tasks, this is definitely a requirement. Otherwise, we can, in terms of, or in cases when our server crashes, we are completely out of data. So that's why we have the persistence, which is pluggable and embeddable again, that could be exposed by different frameworks and technology to be consumed by client application. On the bottom, we have the tools that are actually for authoring. So allows us to build processes, rules, data models, or forms that will be presented for completion of user tasks or starting process instances. Everything that is produced there, it will be stored in the repository. Once we have that, we can then build it and deploy it to the runtime environment. With that, once deployed, we can actually operate on them. And this is where end users comes into the picture and start using the runtime management and reporting. So runtime management is mainly for dealing with process instances and task instances. Whenever a process has a user task that allows us to interact between the system and actually humans, that is where the task list can be used and presented to the user, and based on the user task form, we can collect data from it and continue with execution. jBPM itself, as a platform, service, suite, whatever we call it, is based on standards. And depending on what part of the ecosystem we look at, then there will be a different standard involved. For example, for business process definitions, so modeling processes, we have the BPM and 2, business process modeling and notation version 2. This is de facto the mostly adopted by all other vendors that are doing BPM as well. So this is not only the modeling, but the execution semantics defined there as well. So at least we can know what we can expect from a given activities in the process. For user task lifecycle management, we have the Oasis Web Service human task specification, and for business analysis and business simulation, we have BPCM. This is relatively new standard, so it is still things that needs to be developed there, but at least there is something that you can actually use in your day-to-day work as an analyst. So you can, before you actually run the process, you can simulate and see how it will behave on the execution environment. So at the core, or at the heart of jBPM, we have the core engine. So the core engine is actually the one responsible for executing your processes. And that is natively execution of BPM and 2 definitions. It's solid, stable, quite lightweight execution server written completely in Java. It's embeddable, completely embeddable, so you can actually run on any platform that supports Java runtime environment. By default and automatically integrated with rule engine, which is Joule's Expert, and complex event processing, which is Joule's Fusion. As already mentioned, we have the configurable persistence, so we can define if actually is needed, and it could be defined on different levels. So we can persist the information about the process. The one thing that this is about the core engine, so this is about the process instances. When it comes to user task, this is always using persistence. By default, persistence is based on JPA and the database backend, but it could be replaced with almost any. Of course, requires implementation. There is one used in community as well based on Infinispan, so that could be used for engine persistence as well. Something that I believe is sort of distinguishing jBPM from the other BPM engines is that we have the pluggable persistence strategy for process variables. Each process variable, each process can have different variables, different set of variables. Usually they are just stored as part of the process instance. Whenever process instance is going to be persisted, it will include all the process instance variables as well. But there are some cases where we would like to not make process instance the master of the data that is in the process variable. For one of the examples could be like when we have a process that is like approval for the document or some review workflow of a document. And our documents are stored, for example, in a document management system. So we don't want to bring in a given version of a document into a process instance because once it's there, it most likely will become outdated. It will not have the updates that people can do while the process instance is active. That's why we can use the variable strategies or persistent strategies to define that whenever there is a need to get this document, you will just use document management system as the storage. So process will take that information and fetch the document out of the document management whenever needed and present that, for example, to end user. At the same time, when updates are given, the document will be stored in the document management system as well. So that is first thing that I think is sort of unique for jBPM. Another is so-called work items. jBPM as a process engine is just executing steps in your process, so-called activities. Activities are defined partially by BPM and 2 spec, which defines the default ones: script task, user task, service task, send task, receive task, and so on. But at the same time, BPM 2 spec defines something called abstract task. An abstract task is actually taken by jBPM as an extension point. Behind the abstract task, jBPM introduces so-called work items that are composed of two elements: a work item definition, which defines what actually needs to happen. So it defines like what expected input, expected output. And then we have the second part of the definition, which is the work item handler, which defines how to do it, how to perform the work to actually transform given input to expected output. So based on that, we have the quite flexible items to introduce into the picture of BPM itself, and these are configurable on the project level, or they could be global. So we can import different sets of work item definitions to be reused across our organization. We can define it once as a definition, and then we can just bring it into a different project, so they can just drag and drop as any other activity type. But at the same time, we can have different implementations of that work item definition. Imagine a case where we have a work item that is responsible for example, communicating with a banking system to verifying credibility of a given user. We would like to do that, of course, on production systems, maybe quality assurance system, but we don't want to do it on development systems. So we can just plug it in like a mock or artificial system that is just responding in a different way. So we can actually bind the different implementation for the same work item definition. That means that we don't have to change at all the process definition. This exactly same process definition can execute in different ways on different environments. The binding between the work item and the actual handler is done on the runtime. So the deployment of a given project or process can be bound with different handlers on different environments. So you can just deploy it on test environment with our mock handler that just always says that a given user is good enough to complete the execution, and on production we will always sync with the actual production or banking online system that will allow us to actually execute and then confirm the credibility of a given user. And then we have our assets, so we have our processes, we have our rules, we have our data models, and so on. And how shall we move from that place where we can actually execute that? So to be able to do that, we need to package it. And since version 6, jBPM considers all the assets, like processes, rules, models, and so on, as source artifacts. And as such, they will be packaged as source artifacts. And by default, since this is Java, it will be packaged as a jar file. And actually, it is a bit of extension of a jar file. It's called kjar, a knowledge archive. That the only difference between a kjar and regular jar is a simple, small descriptor within it. In most of the cases, it will be empty. It's just the root tags. It's an XML file. And that is pretty much it. Once it's there, the engine will consider this as a knowledge archive. We'll find all the knowledge assets in it, like processes, and make sure that they compile, they will be built and ready for execution. Kjars can include, and in general it should, include a source code as well. So if we have additional, like for example, we can have handlers, they can be included in kjar itself, or they can be added to the kjar as a dependency of it. So if we'd like to reuse it, so we can package it externally as a jar and make a dependency on our kjar to that given jar. Kjars can have dependencies to other kjars, and by that you can include different assets from different kjars into another one. So you can have like a common cross-organization processes that you know that you would like to include them in every single project you are going to deploy. You can just make a dependency of that kjar to all other kjars, and they will be available for execution. Again, when moving to version 6, we started to use more standard or well-known approaches for packaging. Previously, it was like a proprietary format, binary format for packages. Now it's all based on Apache Maven. But at the same, it's not really tightly coupled with Apache Maven, because you can just generate those jars with Maven, you can generate them with, your preferred tool for building jar files. The only thing is that it must include this K module XML descriptor, and that is pretty much, that's the only requirement for it. But why we use Maven is, yeah, first of all, it's quite well known, at least in Java world. It provides us a unified standard structure of the project itself. So from the source point of view, so we have distinguishing between Java artifacts like a class, then we have resources in different places where we can actually put different assets. Provides and manages the dependency. So this is why we can actually define dependencies that will be resolved on runtime. Whenever you define a dependency to different jars, to different K jars, when you deploy a given project, it will resolve all the dependency and make sure that they will be available on runtime. If not, it will fail during deployment as well. Since Maven comes usually with repositories, we can simply distribute that. So we can have different either public repositories like the Maven repos that are publicly available, or our own organizational level repositories, nexuses, and so on. This is how we can actually distribute that. Once built and packaged, we can actually send that to a given repository, and then almost any single Maven-based application can make use of that. So once we have that in place, we have our cages built, then how we can deploy it, how we can make it available for execution. And that depends actually on the way you use jBPM. jBPM can be used sort of as a service, so you run the full platform, so you have all the jBPM console or Q workbench, as the name is for the entire environment, or you can embed it in your application. It's completely up to you how you would like to use that. When using jBPM as a service, you will directly use cages as the deployment unit. That means this is the only way actually to put assets on the execution environment. So you have to build it and deploy it to the environment. Each deployed artifact will become independent unit on the execution environment. That means no class path clashes. All the dependencies that are brought in by Maven on the project level will stay on the project level only. It will have access as well to the top elements on the class path hierarchy, so everything that is available on the server will be available for project execution as well. But those that are defined on the project level will only be on that project available. It will not interfere with any other projects deployed on the same execution environment. When running embedded, you can actually do it in multiple ways. Recommended would be, again, to do the same based on cages. That gives you the sort of dynamic nature of your system. You can put knowledge archives, remove knowledge archives without shutting down the servers or shutting down the system's server, whatever it is deployed to. But if you don't need this dynamic nature, you can just do it statically. So whenever application starts, you can just fetch certain assets that you want it to deploy to from whatever source, like file system, class path, database, wherever you store them, and just deploy them individually as assets. They will not be then isolated. They will run within the class path of the application itself. So in case of some issues with library versions, then you will run into the class path clashes as well. So having that said, that it can be embedded, and it can be embedded in different ways. There are like 3 levels of API that you can actually consume for running processes, starting from the lowest level, where we have the knowledge API that operates on knowledge sessions, knowledge bases. Then we have the runtime manager that is encapsulating the life cycle of those components. And the third, I think, which is the easiest way to start with, is the services. Services are sort of evolution of different layers of API we have in jBPM, just to simplify. Each layer tries to simplify and hide more and more components of the execution engine. That means that we don't need to think about this plumbing, or how we should configure persistence, how we should register handlers. We just declaratively define what needs to be there, and the engine behind the services will make sure that this is in place. Again, this encapsulates the best practices of runtime usage, so different strategies that are brought in by runtime manager, like this singleton session per process instances and so on. Again, this is hidden, but can still be declaratively said, I want to use that and that strategy. That will be brought in by the service by default. By default, it promotes the dynamic capabilities, the dynamic nature of the system. So that means that you have to deploy assets. And by that, you need to deploy kjars. Since we use kjars, it will promote to use those kjars as the deployment units to somehow enforce the partitioning and isolation of your knowledge. So you can still use the same runtime environment for running, for example, different departments of your organization. HR processes with finance processes can run and coexist on the same runtime environment without interfering with each other. So services by default are sort of divided into building blocks that bring in a certain amount of functionality or capabilities. We're starting with the deployment service. This is where you can put your kjars and remove kjars from the environments. This is just a simple deployment service that can understand what's inside the kjar and how to consume it and how to build the runtime engines for it. Process service and user task service is rather self-explanatory. It means that it can just interact with your processes, interact with your user tasks, and that's pretty much. Runtime data service is all about what has been available on runtime. So whatever process has been executed, whatever task has been executed, you can query it via this service. This always provides you with the most current view of the running system. Definition service is more of finding out what is actually included in your environment. So by that you can set, for example, I'd like to know what is included in this process, what sort of process variables are there. This is more for like building UIs, custom UIs that allows you to, for example, fetch information about the user task, expected input, expected output, so you can present that and build an UI for it. Services are built with just a pure Java, at least the core implementation. There was the whole point that they are composable, so they can be put into different environments. And by different environments, it is like using different frameworks. Same core implementation can be used, for example, to build a CDI-based application. Like, for example, the keyword when jBPM console is based on add-ons on CDI. You can build up your execution services with EGB, both local and remote. This is fully supported and completely covered. If you like, you can use Spring as well. This is just a Spring configuration on top of that needs to just assemble the services and bound them together. For all of this, we have examples. So CDI is the actual jBPM console. For EGB, we have a reward application that is showing how the EGB services can be consumed on the application server. And we have a Spring application as well that is just using the services and provides pretty much the same execution capabilities as Workbench, but of course limited because it doesn't have this form generation and interaction with the data model underneath. But execution capabilities are exactly the same. And why they are exactly the same? Because they actually rely on the same code. They will use exactly the same services. jBPM console, EGB, Spring, whenever they are based on services, they will use exactly the same things. So jBPM services in action. This is actually the implementation, complete implementation of jBPM console, or so-called key workbench as well. That brings in key services or the jBPM services implementation with CDI add-ons, because the application is built on top of CDI. It brings in different frameworks that are relying on CDI capabilities. That's why the CDI add-ons for services are used there as well. jBPM console can be divided into like 3 pieces or 3 big parts. One is the outer ring, which is an UI that can be quite highly customized And by that, this is because of the workbench style of the user interface. So this is like based on the idea of Eclipse workbench. So you have this different panels, perspective panels views inside the workbench that can be moved around, can be closed, open, and reorganized. By that, we provide with the authoring capabilities process designer that is actually for building the BPM and 2 compatible processes. Form modeler for building the forms for both process instances and task instances. Data model, a basic data model editor that allows us to just use a simple UI to create an object that can be then used for processes and rules. Rule editors for guided rules, free-form rules, decision tables, DSLs, etc. for when it comes to the actual building the business rules. And then we have the dashboard for reporting. It could be seen here, it could be seen as a part of the authoring, because you can author some of the dashboard elements, like your own dashboards or defining data sources that you wanted to get information from. And that would cover the main parts of the authoring parts, authoring capabilities of the system. They are covering quite a lot, and all of this stuff is just available over the web. So it could be deployed almost anywhere, and you need to just use web browser to actually perform all the tasks. Once we have that, we can build those packages as part of the authoring perspective. Just by hitting a single button, it will create our kjar. It will deploy to Maven repository. Keyword or jBPM console exposes by itself a Maven repository as well, so you can configure it as any single Maven repository can fetch artifacts from it. And by building all artifacts, kjars will be automatically deployed to that Maven repository as well. When we would like to deploy that automatically to runtime as well, it can be done from within the authoring perspective. So once we are done with authoring tasks, we can just build, deploy it, and that will make our assets available for execution. And then when looking at the execution, we have the process definition in instance management. So this is where we see our processes that are deployed and that can be executed. At the same time, when users interact with this tool, they can see what tasks are assigned to them. And tasks assigned to them, they can claim, complete, and work on those as much as needed. This provides the full lifecycle management and control of user tasks that is defined by human task, web service human task specification. And the runtime engines are actually exposed as remote interfaces as well. So we can communicate with them over REST, JMS, and so at the moment. jBPM provides the storage by default for all authoring assets will be stored under the Git repository that is partitioned into different levels. So each project can be stored in a repository, so it could be a single project per repository. You can have multiple projects in a repository. There could be multiple repositories within organizational unit. So if you look at that from the GitHub point of view, it's pretty much the same. So you can have organization, underneath you have different repositories, and in repositories you can have projects. So this is pretty much similar, pretty much the same layout. Web tooling provides access to the Git assets over the different explorers and different assets editors. But since it is a Git, it exposes a Git server as well. And that Git server can be accessed over the Git protocol or SSH protocol. For Git, it is only it's read-only access, so you can just fetch information from it, but you won't be able to push it back. With SSH, that then enforces you to authorize. Then you can both fetch and push stuff into the from and into the workbench. So you can integrate with your IDEs or other tools that you prefer to use. For example, you can use the continuous integration tools as well to fetch the items from it, build it, and externally push stuff from it. All right, and the business activity monitoring is more for business users that would like to see what is actually running in the system. This is a real-time data information. So whatever you have started, completed, this can be visualized by the business activity monitoring, so-called dashboard. And it's, yeah, as I said, it's completely real-time data. So whenever you, as soon as you operate on it and look at the BAM capabilities, you will see directly the data that are executed by the engine. All right, and sort of conclusion, why we see this as a sort of Swiss knife is that, first of all, you have all the components that are actually needed for BPM. So you have processes, rules, business activity monitoring, complex event processing, forms, data model. This is already available. You don't have to bring in any other components, any other software. You don't have to integrate with anything. You have everything in place. Can be used as a service or embedded. So you can either choose to run the entire platform, or you can just take pieces of it and assemble it in your own way. And by different ways or different levels of being able to embed the project, you can run it in just pure Java or Java standalone. Then you can run it almost on any device. If you like, you can just then go for the enterprise EGV CDI. You can run on the web containers using with Spring. Or if you like, you can just go with web microservices and just make use of the new shiny things like Spring Boot and Vertex. That can be used as well. So, and by that we think that it is quite powerful and seems like a sort of a Swiss knife as well. All right, and last slide just to see this everything in action. We'd like to welcome you on the workshops that starts today at 10 to 4 in room A112. So you can see this actually working and doing the work, different things. Cool, and with that we have like a couple of minutes for questions if you have any. Yes?
Do we have any kind of architectural reference for high availability on this platform?
High availability.
Can you repeat the question? Sorry.
If you have any reference architecture for high availability, then the sort of, I would say it depends what sort of high availability you need. On the runtime data, authoring data, because these are runtime data. Yes, there are definitions of how you can actually run the jBPM in high available way. Usually it comes down that you have to have a single backend database that is shared across all the nodes, and then you can freely distribute those installations of either Key Workbench or jBPM console or your own application in mode of share nothing. They shouldn't be aware of each other. The only thing that you might consider to be shared to make sure that when one node goes down, will be able to pick up, the other will pick up the tasks, and usually it's for timers. So then you have to just configure Quartz for database storage for distributed timers. Besides that, it's share nothing.
Thank you.
Another question?
Any other questions?
Does BPMN, as implemented in jBPM, provide some standard of programming language, like a scripting language that could be embedded in process logic?
By default, jBPM comes with support for Java as the, maybe not scripting, but as a language that you can write scripts in, and Envel. That are two supported scripting that can be used within the processes itself.
Okay, thanks.
Maybe may I ask you about the performance?
May I ask you about the performance? As you said, there is a lot of layers around service processing.
Yeah, actually the performance depends on the logic and the implementation of the work items that process is executing. Process engine itself has an overhead of 20 milliseconds on each node. That's it. And then question is, what will actually happen as part of the execution of the process?
Okay, you mean 20 seconds on single process or single activity?
20 milliseconds.
Yeah, on single activity.
Yeah. It shouldn't have more than that, and that is including the transaction management as well. Because the transaction management, whenever persistence is enabled, is taking the most of the time. The process engine itself is rather fast, and then if you have like a long-running items in your process, then you shouldn't do it as part of the execution of the process, but you should do it in a asynchronous way, like in a background. And jBPM provides so-called jBPM executor, so you can define that a given logic that should be executed in the background, and you can just put it that, yeah, whenever process reach this step, it will run this logic in background, and as soon as it's completed, it will notify the process to move on. So that's why you can just remove the burden from engine to wait on something, and by that sort of directly impact the performance, because that will be seen as an impact of the performance for the process engine itself. But you can just delegate that to asynchronous work, and as soon as that is completed, the process will continue. Because actually process engine does not really care what it executes. It just told to execute it, so it executes it. If it's long running and it's not asynchronous, it will wait. And usually when it's really long running, then it will time out the transaction as well.
Okay, thank you very much. So the time is up. So if you have any more questions, you can follow up in the lobby or somewhere.
All right, thank you very much.
Thanks a lot for the talk.
Będę mógł z Tobą porozmawiać
Jasne.
o BPM-ach,
Jasne, nie ma problemu.
żeby Ci to za dużo czasu nie zabrać, jeśli teraz...
Nie, ja mam teraz do 15 coś, do 15:50 mam czas, bo jest ten.
Super.
No, nie ma problemu, już tylko się spakuje i...
Lukáši, můžu si tady u tebe nechat na povídání budu.
Jo, snad jiné černé.
Pár knížečkou, knížky.
Kde máš ty rozbitý dveře?
Ty jsou tam ven jako.
Vstup do Dčka normálně rozbitý. Jo?
Aha, já jsem myslel, že tady u vás.
Ne, ty prosklený, ty jo.
Aha.
Możemy się na pewno
Jo, tady normálně.
Thank you for the presentation. Thank you. Right on the